Stephanie Tanner will be presenting with Holly Cannon this morning. Stephanie is the lead engineer for the U.S. Environmental Protection Agency's WaterSense program. She is responsible for all technical aspects of the development of labeled products, including setting efficiency and performance criteria, as well as managing the certification process. Her presentation today will elaborate on aspects of the development process. She holds a Bachelor of Science degree in Marine Engineering from the Merchant Marine Academy and a Master of Engineering Management from the George Washington University. Holly Cannon is an environmental scientist with Eastern Research Group Incorporated with expertise in water efficiency. Holly's work focuses on developing technical specifications for recognizing water-efficient products and practices, developing best management practices for water efficiency in commercial and institutional facilities, and conducting water use and conservation assessments at federal facilities. As a contractor to EPA's WaterSense program, Holly has led a field study to evaluate long-term water savings and performance of pre-rinse spray valves, and she is currently working to develop efficiency and performance criteria for these products. She holds a Bachelor of Science degree in Environmental Science from Virginia Tech. So please welcome Stephanie Tanner and Holly Cannon.
Good morning. It's great to be here in my hometown and not have to travel, because we can't go anywhere, really, at EPA anymore. So once again, I'm here to talk about some recent research we've been doing, I think it's a little close, at the EPA on product performance. 2 years ago, when we had this symposium in California, we came and talked about our recent research on shower heads, and basically we've been building on that to do this research we have now on pre-rinse spray valves. So for those of you who don't know, which I'm not sure how many of you there are, WaterSense is a voluntary program by the EPA, and we were founded in 2006, and our basic goal is to try and help consumers identify high-performing, high-efficiency products. Generally, our products we try and aim for about 20% savings, and we try and make sure that the label is backed by third-party certification of all of our products. When we're looking at products, we're generally looking for 7 different criteria that to decide whether we're going to try and label them or not. We look for products that offer superior performance, that are, like I said, about 20% more efficient, that have many different ways for them to achieve the efficiency, because we don't set proprietary criteria for our products, and we want them to be effectively differentiated in the marketplace by the label that we have, and then they all have to be independently certified. So since 2006, WaterSense has labeled 5 different products: tank-type toilets, laboratory faucets and bar sink faucets, flushing urinals, shower heads, and most recently, irrigation controllers. And since then, even though our new numbers are about to come out, the old numbers said that we had saved over 120 billion gallons of water, and we've shipped over 55 million products with the label on it. We've started doing pre-rinse spray valves because they do account for a lot of water in commercial kitchens. They use a lot of water, and because most of the water is hot, they also use a lot of energy. In 2005, the Department of Energy set new national standards for pre-rinse spray valves, and they included a 1.6 gallon per minute flow rate, but they did not include a performance requirement. The new flow rates since then there have been a lot of technologies that have come out with flow rates under 1.0 gallons per minute. And we've been considering this product in conjunction with the Energy Star program because of its because of the potential to save energy. But part of the problem is that a number of our stakeholders felt that the product performance test that existed was really designed for a different purpose, and they started to feel like there may be some performance performance issues with the products in the field. The existing performance test for these is basically a cleanability test designed by ASTM, where you basically use the spray valve to clean tomato paste off each plate, and you time the amount of time that takes. And you get a score basically in seconds per plate. Like I said, a lot of our stakeholders that had been doing some small-scale pilot tests on these were finding that they were having a little bit of difficulty with the products once they got in the field. There were some complaints from users. And so when we started looking into the product for WaterSense labeling, a lot of our stakeholders asked us to do a little bit more investigation into what the problems were. So we designed a field study for that. And basically, the objectives of the study were to look and see whether people were actually saving water in the field. There was some concern that because they were using so little water, that people were actually taking more time to clean the plates, and that would then cause them to use more energy and water than we were thinking, and the savings would be lower than they had expected. There was some concern that users weren't actually satisfied, even though these high-efficiency valves did score well on the existing cleanability test. And so we wanted to test that and make sure that the cleanability test was actually indicative of product performance. And so with that, I'm going to turn it over to Holly, who was the lead researcher on the product.
Thanks, Stephanie. So we worked with an ASME CSA project team to develop the study objectives and the study scope. And once we'd had that all framed out, we started collecting data. From January through June of 2010, we collected data on pre-rinse spray valves at 10 commercial kitchens in the Boston and Washington, D.C. areas. And 4 of those 10 participants were university dining halls, 2 at Harvard University and 2 at Boston College. 1 was a high school cafeteria, and the other 5 were restaurant facilities. We really wanted to get a wide range of sizes of facilities and food types when we collected our data. They ranged in size from a small restaurant serving 1,200 customers per week all the way up to one of the bigger dining halls was serving 35,000 meals per week. So what we did was we monitored each of the facilities' existing pre-rinse spray valves for 3 weeks, and 5 of those facilities had non-EPAC compliant spray valves. The EPAC maximum flow rate is 1.6 gallons per minute, and these non-EPAC compliant valves can flow upwards of 3 to 4 gallons per minute. The other 5 facilities had EPAC compliant valves that we actually studied in other facilities as well. After we monitored the existing spray valve, we installed 3 new spray valves and monitored those for 3 weeks each. And we looked at 14 total models, and we broke those models down into 3 different flow rate categories. And those are listed here, a higher flow rate category, a medium, and then that ultra high efficiency category of less than 1 gallon per minute. And since we were collecting user satisfaction data, we really wanted to make sure that we had at least 2 users evaluating each pre-rinse spray valve, so each of the models were tested in at least 2 facilities. To collect our water use and use time data, we installed water meters on the mixed water line after the hot and cold mixing valve, but before the spray valve, and we attached a data logger onto that, and that data logger recorded an average flow rate over time. It was a flow rate recording over every 10-second period, and we were able to use that to back calculate the use time over the 3-week period, and then also use the meter data to determine the total water use over the 3-week period. Each week, we would go to the facility to download the data logger data, and we'd also collect some additional criteria, the water temperature that the users were using to rinse the plates, the operating flow rate of the pre-rinse spray valve in the field, and the static and flowing water pressure. At the end of each 3-week period, one of the really interesting aspects of this study is we actually interviewed the users to find out what they liked about the spray valves, what they didn't like, and we asked them to rate a few specific criteria: the pressure or perceived spray force of the spray valve, its ability to clean dishes, its spray pattern, and then their overall satisfaction with the valve. And we took all of our data, the water use, use time, user satisfaction, the operating flow rate, and we conducted several analyses to try to look back at our research objectives to see what we concluded. So I'm going to talk through those results in the coming slides. So the first analysis we did, water savings is very important, and as Stephanie mentioned, some stakeholders were concerned that the high-efficiency valves were taking users longer to actually rinse the food waste from the plates. So we wanted to make sure that that wasn't happening. You know, WaterSense really wants to label products that save 20% of water, so we wanted to make sure the high-efficiency valves would be able to meet that criteria. So we made a few graphs, and I'm going to sort of explain how this is set up. Each point on the graph is a pre-rinse spray valve, and this graph in particular shows the water use in gallons per day versus the operating flow rate in gallons per minute. And we really, since all the facilities had very different operating criteria, they served a different amount of meals, were open different amount of time, served different food, we wanted to look at the trends among the facilities to see what we can conclude rather than comparing straight, water use apples to apples. It wasn't really possible. So each facility, the spray valves tested at each facility are linked by a line, and we're looking now here at the trends. So what we can see is as the flow rate increases, the water use also increases. There's a pretty consistent trend, increasing to the right, decreasing to the left, and we felt confident that the high-efficiency spray valves were, in fact, using less water. And that also indicated to us that the use time was likely not increasing enough that it would offset water savings. So to take a closer look at the use time, we developed a similar graph plotting the field use time in minutes per day along with the operating flow rate. And the results here are a little bit different. They're not completely consistent from facility to facility, but in general, the lines are all pretty flat. So we concluded that use time remained fairly consistent regardless of the pre-rinse spray valve operating flow rate. And that supported our conclusion that there was water savings with the high efficiency valves as well. I also want to point out one quick thing about all these graphs. We only looked and plotted the data for the EPAC compliant valves. We really wanted to look at the products available on the market now and compare the highest flowing products available on the market now to the lowest flowing products. Later we'll look at some water savings from the EPAC or the non-EPAC compliant valves, but in terms of our general conclusions, we wanted to look at what's currently available. So Stephanie also touched on this laboratory use test, this cleanability test, and there were some concerns that it may not be accurately indicating which spray valves would be used for longer in the field, or if users preferred one spray valve over the other in the field. So we wanted to take a close look at that. And we plotted the field use time in minutes per day against the laboratory use time in seconds per plate. And results here are similar to the last graph. The lines are all pretty flat, again indicating that use time remained fairly consistent regardless of here the laboratory use time or cleanability. So we felt that the cleanability test may not completely indicate how long a spray valve would be used in the field or which spray valves would be used longer. Our user satisfaction data was a very important aspect of the study, and we really wanted to pay attention to what the users said and how they felt about the valves. So here what we did was we grouped all the spray valves based on the flow rate categories that I showed you earlier, and then we took a look at how frequently the users were satisfied with the valves, were somewhat satisfied, or were not satisfied. And what we found was above 1.0 gallons per minute, users were pretty consistently satisfied. Over 70% of the time, they were completely satisfied with the valves. But as the flow rate decreased to below 1 gallon per minute, satisfaction really dropped off, and about 50% of the users were unsatisfied. So we felt there was a pretty clear cutoff there with user satisfaction in regards to flow rate. So back to this laboratory use time, we also wanted to take a look at that as compared to user satisfaction. So we plotted those two criteria. And what we found was there were several spray valves that had the same laboratory cleanability time. So if you'll take a look at the 21 seconds per plate column, there's several user satisfaction ratings there, and it sort of ranged across the board. Some were unsatisfied, some were satisfied. It really didn't seem to completely depend what the cleanability time was. We had expected to maybe see that the lower cleanability times were more preferred, so there would be a cluster in the top left part of that graph, and then the higher cleanability times were less preferred, so a cluster in the bottom right, and that really wasn't the case. It was sort of across the board. Users couldn't really perceive a difference between that laboratory cleanability time. And I do also want to caveat this data. The spray valves, we tested 14 models. They're all EPAC compliant, and they all have a cleanability time of 26 seconds per plate or less. So these data we felt were pretty conclusive in terms of the models that we tested, but we can't really make any conclusions about spray valves with higher cleanability times or those non-EPAC compliant valves. So the user satisfaction results, we took a close look at those models that users determined were unsatisfactory, and we looked at why they said that. And there were really two themes that stuck out. One was that they were concerned that the spray valves were too slow. It was taking them longer to rinse the food waste from the plates. And our data didn't support that. Our data showed that use time remained fairly consistent, but it was an important piece of feedback. And then the other consistent trend is that users thought that the spray valves had poor pressure or weak spray force, and they couldn't get the plates clean because the spray force wasn't enough. So that was a very common theme in their dissatisfaction. So I mentioned the water use. I'm really going to run through this slide pretty quickly in the interest of time, but we wanted to put some hard numbers to that water savings just to make sure that these high-efficiency valves were saving water. So we took the 3-week data set of water use and we extrapolated that out to a year, and this graph shows that typically, in most cases, the Category 1 valves, the higher flowing valves, are using more than the Category 2, and those are using more than the Category 3. And then this next table shows the non-EPAC compliant valves, and water use can also almost be decreased by about 50% by installing a Category 2 or Category 3 high-efficiency valve. So water and energy savings can be pretty significant from changing those non-EPAC compliant valves out, and there are a significant amount of those still out there on the market, even though the EPAC 2005 set that 1.6 maximum. So the study observations, as we mentioned, the high-efficiency spray valves in general saved water and energy. We didn't talk too much about energy, but that hot water use factor does allow them to save energy as well as water. And the high-efficiency spray valves did not require additional use time and did not completely offset the expected water savings. The laboratory use time didn't seem to provide an accurate indicator of user preference or of actual use time in the field, so we concluded that another laboratory test may need to be developed to differentiate performance of spray valves. And we also found that users in general were less satisfied with those valves less than 1 gallon per minute, but we didn't think that was totally attributed to flow rate, since they were citing things like poor pressure and slower clean time and things like that. So after we analyzed the results, we went back to our ASME CSA project team, and we've been collaborating with that group a lot. They've been great to work with, and we came to the conclusion they didn't think that setting a minimum was really the right approach. So they didn't want WaterSense to say, all spray valves below 1 GPM wouldn't get the label. They really didn't want to stifle manufacturer innovation in that way. They wanted a performance test that would more accurately choose which products could get the label. So we decided to explore a force test similar to the WaterSense showerhead specification. It's a force balance test, and we had the 6 labs that are part of our project team volunteered to collect data using that force test. And we looked at that data, and it came out pretty good, but it wasn't completely repeatable and reproducible. So we decided to modify that a little bit for the spray valve setting. And Bill Golly, actually, with Veritech Consulting, he's in the back there. He did a lot of work putting together this revised protocol. And we tried to eliminate any friction, any moving parts, and really get a direct reading of force. So it's essentially a force gauge directly affixed to a spray disc, and you're spraying the valve directly on that spray disc to get a force reading. It's pretty simple, and the 6 labs are currently collecting data using this new protocol now. And here's some pictures that Bill took when he was developing it. It's not the official pretty lab version, but it is the development of this new force test and how he put that together. So you can again see that force gauge is affixed to a plate in a vertical fashion, and it's really a pretty direct measure with very few moving parts. So force testing is wrapping up actually this week as we speak, and we're going to discuss our results during the ASME CSA meeting in Quebec City in June with our project team. And if that data is repeatable and reproducible, we're hoping to compare that back to our user satisfaction data that we collected as part of this study, and hopefully determine if that force test better correlates to user preference and better correlates to actual field use time. And if so, if the data comes back and it's good and it does seem to indicate product performance, then we're anticipating a draft specification release in fall of 2012. And this would be the first product that's a dual label with WaterSense and Energy Star. So it's really exciting for both of those programs. And the performance and water efficiency criteria that we're putting together would also be incorporated into the National Plumbing Standard. And that's it. At this point, I'll take any questions, and feel free to contact Stephanie and I right there as well.
Craig Sillover with Masco Corporation. It's interesting. This is kind of interesting, and I want to pay you a compliment on the work that you've done, both on shower heads and here. There's a revised Executive Branch OMB Circular 119, which has to do with encouraging federal agencies to participate in voluntary consensus standards process, which you're doing. And yesterday was the deadline for submitting comments, and they're having a workshop here at NIST in 2 weeks. And I submitted a comment yesterday, and I complimented WaterSense program as an example for the challenges we have with respect to water conservation. If we only take a look at how do we just get it lower and lower and lower, that's all well and good, and that challenges manufacturers from an innovation standpoint to figure out how to do it. But a really important point that I made in my comment on the OMB circular had to do with the fact that federal agencies need to be engaging with the marketplace, because what we end up with needs to to encourage us to innovate, but to make sure that we're able to provide the utility to the consumers at the end of the day. And so the work that you're doing here is a really excellent example of a federal agency working with the system and doing marketplace research as well to make sure that we can provide the proper utility and have the right challenges for our innovation. Thank you.
Thank you. It's always nice to hear something positive.
This is a question for Stephanie. I think you were using the time per plate, something like 20 to 26 seconds. Was that right?
Right.
And this is for pre-rinsing before going into a washer.
Right.
Is that it? Mm-hmm. It seems like a long time for pre-rinsing. Is that really the typical expected amount of time that would go into a plate pre-rinse?
I
mean,
think we found that it was
seconds.
a lot. We thought it was a lot shorter than that.
Yeah,
wasn't
so
it?
that
Yeah.
number is that's from a laboratory test, and that's designed where tomato paste is actually almost baked onto the plate, and then you're removing
Right.
that tomato paste in full. So that's the laboratory test. That's definitely far longer than a user would actually spend in the field, and the food actually wouldn't be caked onto that degree either in most cases.
Right. And it's part of, like, I think in California, they require the cleanability test, and it has a limit. And so I think it's 26 seconds. And so we just selected things that basically were below that. They're usually much lower than that.
Yeah, okay.
In total.
Thank you.
Just a general question on the WaterSense stamp. Your limits for efficiency, are they a moving target over the years and people need to requalify? Or is it a one-time stamp and you're good for life?
You're good until we change the standard. But it takes a while, And I think when we first set up the program, we thought we would change it every 3 or 4 years. That's the rate at which basically our sister program, Energy Star, changes theirs, sometimes sooner. But generally, the plumbing industry does not move as quickly as, say, telecommunications. And so we found that our products still are viable in the marketplace and that the standards are still acceptable, like 6 or 7 years later. And so we agree to review them at some point in time. We review them every 3 or 4 years, but we haven't actually changed any of them yet. And when we do, it's a 2 or 3 year process, and then there's a transition time for manufacturers. So I think there's plenty of time for manufacturers to get into the marketplace with the WaterSense label and then participate in the revision of the standard of our specification and then prepare themselves to make that transition.
Is it a single level accreditation?
It
or
is.
Yeah.
Yeah.
Yeah. Thank you.
Hi, Janet Stout from Special Pathogens Laboratory. I have two questions. One I might have missed early. Was there a control group where you've got people using the low-flow energy-saving devices versus those that are using kind of the standard under the same conditions? So that's the first question. And then the second one is, do these devices have, like, two-flow options, much like, in Europe you have the toilets that have two-flow options, and I'm wondering if you could sort of have the best of both worlds if you had that option on these devices.
Yeah, to your first question, I may have missed it. So we tested the existing spray valve for 3 weeks at each facility, so whatever they had installed when we walked in the door. Then we installed 3 new ones, one in each of those 3 flow rate categories, and those were installed at random. So the user didn't know what the flow rate was or what model was installed. I don't know if that answers your question. There wasn't totally a control group, but everyone tested everything, essentially. And your second question, the multiple mode, there are a couple of models that have multiple modes, but they're typically around the same flow rate. It's more of a different spray pattern. So spray valves have 3 typical spray patterns: a fan spray, a single jet spray, and then sort of a tri-spray. And there are a couple of models that incorporate all of those.
Just to follow up, which organizations do the third-party certifications on these kinds of products?
We have 7 certifiers. I always forget one, so please forgive me if I forget one. Well, IAPMA R&T, ICCES, UL, WQA, Intertech, and NSF, and one other.
CSA?
CSA. Sorry, CSA, if you're here. Yeah. So those are our certifying bodies, and they're all accredited by ANSI to our scheme. And if there's another one out here who's interested, we're always, people are always coming and going. So
the force testing that we did, many of those testing bodies are conducting that force testing and preps for potential spray valve specification. So we're working with them through this process of determining a performance test.
Right. So, but our test project is a ASME subcommittee, so it's made up of manufacturers and testing bodies as part of that. So.
I noticed that one of the restaurants was Founding Fathers, which is an organic, locally grown green restaurant here in the area, and obviously working with the universities, possibly a more green ethic among the users. Was there any indication, I don't know if it was a control factor or just showed up in the comments, that having users that were more aware of the importance of saving water or other greenness had any impact on user satisfaction? You said that it was a blind study, so they didn't know which one they were using, but just the concept that they might be using something that's saving more water, was that impacting the satisfaction?
Right. Well, that's true. We did work with a couple of Green Restaurant Association certified restaurants, but the folks who are making the purchasing decisions and the management decisions, those would be the green-minded folks. The users of these there's a high turnover of users in terms of a dishwasher. They're not really necessarily aware of those management decisions being made. They're kind of just using whatever you put in. So a couple of the users did seem to be on board with and understand our process. A couple of them didn't even speak English, so we were actually giving them the user satisfaction survey in other languages, and I don't think they were totally even aware that they were using low-flow products and really what the impact was. So I would say the answer to that is probably no. You know, I don't think that users were necessarily more or less satisfied based on their restaurant's position.
Okay, we have time for another question or two, either on the pre-rinse spray valve study or general WaterSense questions.
I have a
Pete?
question. Yeah. Pete DeMarco with IATMO. Stephanie, what's next for WaterSense?
Besides pre-rinse spray valve?
Yeah.
Well, I think this year we're spending a lot of time working on our commercial buildings program. We've started doing a lot more collaboration with Energy Star. They have a much bigger commercial buildings program where we've got a lot of feedback from our stakeholders that they would like to see us try and do more work there and to try and work towards some kind of a building label or building rating. And so we've been putting a little bit of time in trying to figure out if there's the data for that is available, and to see how we can sort of get better information out to building owners about water management in buildings. With the help of Bill Hoffman and John Keller, we've developed a set of best management practices, and I know we've been saying for a long time that they're imminently going to come out, and they actually are imminently going to come out. So hopefully sometime this summer we'll be releasing our best management practices for commercial buildings, and then we are also revising our new home specification, and that basically is it's not really a revision, it's just a modification to make it applicable to multifamily housing. After we sort of got into the market at the right time when the housing market took a huge nosedive, we got a lot of feedback from some of our builders that they had actually built some multifamily housing that they thought could qualify for the WaterSense label, but it wasn't eligible. So since that is the one area of the housing market that seems to be doing a little bit better, we're trying to make that specification more applicable to multifamily housing. But we have labeled about 50 or 60 homes in the last few years, and it's starting to take up now, and a lot of our builders are actually starting to offer WaterSense as a option that people can buy basically anywhere in the country and not just have like WaterSense developments in small pockets of the country. So that's it.
Well, we are right on time, so we want to thank Holly and Stephanie for their presentation, and